Hello guys, this is the lesson that is going to walk you through the rules for how to write Lewis structures for covalent compounds. So you listened to the lesson yesterday and it talked about how covalent bonds that form covalent compounds are different than ionic bonds. And they're different mainly because they share valence electrons instead of transfer them. So these are going to be molecules that are composed of just non-metals. So you won't see sodium or potassium or lithium or any of the metals because when those combine with non-metals, they make ionic bonds and ionic compounds. So listen to the video, take notes, and then I'll give you some practice ones to do after the video is done. So I used Cami to add to these slides so that you can see what each rule is asking you to do. These slides are on Canvas. They're not going to have my drawings and notes on them. So again, make sure you are taking notes. So rule number one is when you are given the formula of a compound to draw the Lewis structure for, the first thing you're going to do is add up the total number of valence electrons for each atom in the molecule. Okay, so you'll have your periodic table handy, and this is the compound CCl4. So you have to know, or you have to go to your periodic table, and you have to see how many valence electrons carbon has, okay? And that's where this number comes from right here, the 4. And then chlorine has 7 valence electrons. So that's here, but then I have 4 chlorine atoms. So I have to multiply those 7 valence electrons for each chlorine times 4. So 4 plus 7 times 4, which is 28, is 32. So that's my first rule and my first number that I'm going to write down. And I abbreviate that TVE, which stands for total valence electrons. So it's just a lot easier to write TVE than total valence electrons each time. The next rule, you're going to write out the elements of the molecule so that the least electronegative element is in the center and is surrounded by the other elements. Now, if you remember from your periodic trends, the most electronegative elements are up here in this top right corner. So fluorine would be the most electronegative element, but chlorine would be more electronegative than carbon. Plus, just start to learn and get used to the fact that carbon is an atom that likes to be at the center of a molecule. So I went ahead and put carbon in the middle, and I surrounded it by the 4 chlorines. Rule number 3 is then go ahead and place a covalent bond, and we represent a bond by a dash. Right, and each bond is basically a pair of electrons. So it's 2 electrons being shared between the 2 atoms. So I went ahead and drew C with the 4 Cl's around it, and then I placed a line connecting the C to each of the Cl's that are around it. So I'm going to remember that each bond contains 2 electrons, and I'm going to write that down, and I'm going to call those the bonding electrons, and make sure I add up that number. So right here, I have 4 dashes or 4 bonds, and there's 2 electrons in each. So 4 times 2 is 8. So far, out of my 32 total valence electrons, right, I have used up 8 of them. That is my bonding or bonded electrons. Rule 4, you're going to add electrons to the outer atoms as lone pairs until you've satisfied the octet rule. So remember, every atom wants to have 8 electrons. They could be in a bond, like a dash, or they could be as lone pairs with the dots just next to each other. So at this point, to figure out how many lone pair of electrons I have, I'm going to take my total electrons at the start, which was 32, and I'm going to subtract the number of bonded electrons, which was 8. So now I have 24 electrons that need to be placed as lone pairs around the outer atoms until I satisfy the octet rule. Okay, so each chlorine basically gets 6 or 3 pairs of lone pair electrons. So they each have 6 there, and then they have the 2 that are contained in that bond. So when you do it in that way, it's satisfying the octet rule because each chlorine has 2, 4, 6, 8 electrons around it, and the carbon has 2, 4, 6, 8 because they're all bonded, but that still counts. So then here I just did, okay, I have 24 lone pair of electrons. I placed those 24 around the 4 chlorine atoms, and so I have 0 electrons left that I have to place anywhere because Rule 5 says if there are still unused electrons, you have to add those to the central atom. And this may not apply to every molecule. I don't have any unused electrons, so this rule is not applicable here because all electrons are being used. And finally, Rule 6, which is really important, is to check that all atoms in the molecule have 8 electrons. There are some exceptions. Remember, hydrogen only wants 2. And if an atom has fewer than 8 electrons, you're going to create double or triple bonds, and I'll show you some examples of that in just a minute. So I redrew my Lewis structure for CCl4, and I tried to draw a circle so that you could see that each atom does have 8 electrons. So again, if you look, each chlorine has 2, 4, 6 electrons as lone pairs, and then 2 that are bonded to the central carbon. So that's 8 total. And if you look at the carbon, 2 in every bond, 2, 4, 6, 8. So it has 8. Okay. Here are some examples I've worked out for you and shown you how to do. I follow those steps every time I do it. Now I might go a little bit faster and get to drawing the structure faster just because I've been doing it longer, but you will want to follow those steps, those rules every time. Don't skip a step because that's going to be really important to help you draw a correct Lewis structure. So the first one is O3. This is the formula for ozone. I'm going to count up total valence electrons. So it's got 3 oxygens, and each oxygen has 6 valence electrons, so that's 18 total. So then I draw my 3 oxygens kind of right in a row, and I'm going to put 1 bond between the 2 oxygens on the outside and connect it to the one in the middle. And I'm going to count up how many electrons I used. So at the start, I only had 4, okay? And then I placed the rest of the electrons, which you have to do, remember, total valence electrons minus bonded, so 18 minus 4 is 14. So I have to place those around the outer atoms first. So I did 2, 4, 6 around this oxygen, came over here, 2, 4, 6 around this oxygen. And that's only 12. And so rule number 5 is if there's still unused electrons, you have to add it to the central atom. So this one is an example where I had to add those last 2 electrons to the central oxygen to give me 14 lone pair of electrons. Now here's where a little bit of the trickiness comes in. But again, once you do this enough, it becomes easier and easier to do the more you practice. So what I did is, I'm going to show you here. I am counting and I'm looking and I'm seeing that, you know what, this oxygen has 2, 4, 6, 8. This oxygen at first, before I drew this second line here, had 2, 4, 6, 8. So that one had 8. It followed the octet rule. But this middle oxygen only had the bond here, which is 2, this bond, the top one here, which is 4, and then the 2 lone pairs up here, which made 6. It did not follow the octet rule, okay? And so rule 6 says you have to make double or triple bonds so that all atoms can have 8. So what ends up happening is, and this has a resonance structure because really either of the 2 oxygen outer atoms could actually kind of move one of their lone pairs of electrons. and put it in an extra bond. So the first way I just drew it, this oxygen on the right would take one of its lone pair of electrons and just shift it here into the middle. And then I drew that second bottom line there. So this bond here, it would be a double bond and contain 4 electrons. And then we can then go back and like erase. I didn't really want to erase the line, but I could erase the 2. It's not letting me erase it. There we go. Those 2 electrons to show that they now physically moved from this oxygen to a bond in between. And now this oxygen should have 2, 4, 6, 8 electrons. This oxygen has 8. It has only 2 lone pair of electrons, and the other 4 electrons are in bonds. And then you could draw it this way where the double bond occurs on the left side, because this oxygen can kind of donate a pair of its electrons. The next one here is the ammonium ion. So your polyatomic ions that contain covalent bonds within them, but that have either an excess or not enough electrons. So in order to count up the total valence electrons for something like ammonium, you still do it like I say, nitrogen has 5, each hydrogen has 1 times 4, so that's 4. But then I see this plus, and remember, if you see a positive charge, it means you lost electrons. So positive means you lost. So I have to subtract. So I had 9, but I lost 1, so I have 8 total. And then I put my nitrogen atom in the middle. Hydrogen atoms always go around the outside. And then I place a bond between that nitrogen and each of the hydrogens. And I count up 2, 4, 6, 8 bonded electrons. So I am done because I have 8 total valence electrons. I just used 8 in my bonds, so I'm done. Now, because this one, again, is a polyatomic ion, after we get the structure drawn, put it in brackets and put that charge outside of the brackets at the top, kind of like an exponent. Okay. The last one here is the cyanide ion, and this is just a molecule that has a carbon and nitrogen, but it has a -1 charge. So we do it the same way we did ammonium, except this time because it's a negative charge, I'm going to add an electron. So carbon has 4 valence electron, nitrogen has 5, and then I add 1 more because the overall molecule has a -1 charge. So negative charge means you've added electrons. 4 plus 5 plus 1 is 10. So I have 10 total electrons. When I first draw the C and the N, all I had was the, I'm going to do this real quick. So when I started this and I drew the C and the N right next to each other, and I connect them with a bond. That's it, right? So in that one bond, there's only 2 electrons. So I only have 2 bonded electrons. And then to find how many lone pairs, I do total valence 10 minus 2, so that's 8. So now I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've drawn all 8. Cool. So I use them all up. I don't have any more. Okay, but the last rule, rule 6, is you have to make sure that every atom is following the octet rule. Well, nitrogen, 2, 4, 6, 8 is fine. Carbon is not. It only has 2 here and 2 in the bond, which is 4. Okay, so again, what we need to do is we need to take a pair here, and we need to make it share with the carbon. So then we move those there, okay? And we can erase then these pair because they're not lone pair anymore. They moved to form a bond between the nitrogen and carbon. And we're going to do the same thing again because nitrogen has more to spare. We're going to do that and they're going to go here and form a bond. And then we can erase those because they simply moved from being a lone pair on the nitrogen to a bond between the carbon and nitrogen. And now the carbon has 2, 4, 6, 8. So that it's following the octet rule. This nitrogen has 2, 4, 6, 8 electrons. Okay. So I know at first this is a little tricky. Like I said, we're going to do lots of examples, and I'm going to give you some to try for homework. That's it, guys.